Let us take a moment, pause, take a deep, slow breath. We have just journeyed through a dense and perplexing mystery. We've spent time wrestling with an object that defies easy explanation in the Visitor 3i Atlas. Like Oumuamua, before it, this traveller from afar has challenged our understanding and perhaps our sense of solitude in the cosmos. The intensity of such an encounter is palpable. When an anomaly like this enters our small, well-lit corner of the universe, it generates friction. It forces us to confront the limits of our knowledge. We poke and prod at the data, searching for familiar patterns. We debate its origins, its composition, its behaviour. Is it a comet, an asteroid? Is it something else? The questions are heavy, and the atmosphere surrounding them is thick with speculation, excitement, and even a touch of anxiety. We have been staring at the thing itself, turning it over and over in our minds, captivated by its strangeness. But this focus, while necessary, is incomplete. 3i, Atlas, and Oumuamua are not just puzzles to be solved, they are messengers. And the message they carry is not just about what they are, but about where they have been. The real profound question that hangs in the silence after their passage is not just, what are you? It is, where did you come from? They came from the outside. They are emissaries from the great dark expanse between the stars. They come from the interstellar void. This word void is a problem. It is a failure of our language and our imagination. When we look up at the night sky, we see points of light, the stars separated by what we perceive as absolute blackness. We call this space a word that implies absence. We think of it as a sterile, dead, featureless vacuum, a perfect nothing. This is fundamentally wrong. The space between the star, the interstellar space that 3 Atlas crossed to reach us, is not empty. It is not a void, it is a place, it is an environment. We must erase the image of a black empty box. Instead, let us visualize it as the prompt suggests, a thin ocean. Imagine an ocean. You think of water pressure currents life. Now take that ocean and stretch it out, thin it out, dilute it to an almost unimaginable degree until the individual molecules of water are meters or even kilometers apart. This is the interstellar medium. It is not a dense liquid, but it is also not nothing. It is a tenuous, ghostly presence that fills everything. Let's build at this thin ocean in our minds. Picture it as a vast cosmic mist. What is this mist made of? The most common ingredient is hydrogen. Single atoms of hydrogen, the simplest and most abundant element born in the first minutes after the Big Bang. They are scattered everywhere, drifting alone. On average, in the vast ocean between stars, you might find only one hydrogen atom in a cubic centimetre of space, a volume the size of a sugar cube. For perspective, that same sugar cube-sized volume of the air we are breathing right now contains about 30 million trillion molecules. The difference in density is staggering. This is why we call it a vacuum. But it is not a perfect vacuum. Those single atoms add up. Across the span of light years, they form an immense diffuse sea of gas. And it is not just hydrogen. Woven into this gas are tiny microscopic particles of dust. This is not the dust that settles on your bookshelf. This is cosmic soot. It is made of complex molecules, grains of silicate like fine to sand grains of carbon, and tiny mantles of frozen water, methane and ammonia. Where did this dust come from? It was forged in the hearts of stars that lived and died long before our sun was born. When massive stars explode as supernovae, they blast these heavy elements out into the galaxy. When old stars like our sun eventually die, they gently puff off their outer layers, seeding space with the carbon and oxygen they created. This dust is the recycled ashes of dead stars. It is the very same material from which new stars, new planets, and eventually we are made. This mist of gas and dust is not still. It is alive with invisible forces. Vast, unseen magnetic fields generated by the rotation of our entire galaxy stretch across thousands of light years like immense invisible strands of silk. These fields guide the flow of the gas, shaping it, corralling it into swirling filaments and colossal wispy clouds. And this space is not perfectly dark. It is bathed in a faint, pervasive glow, the combined, diluted light from every star in the galaxy. It is a cold, weak light, but it is relentless. It warms the tiny dust grains just a few degrees above absolute zero and subtly changes the chemistry of the gas. High-energy particles called cosmic rays fired from ancient supernovae zip through this medium in all directions like invisible bullets. This is the ocean that 3i Atlas swam through. Try to comprehend its journey. It was not a sterile sprint from point A to point B through an empty corridor. It was a voyage. It was a long, slow drift through a substance. For millions, perhaps hundreds of millions of years, this object was fully immersed in the interstellar medium. It was a lonely, silent journey in profound darkness and cold. As it moved, it was constantly subtly interacting with its environment. Lone hydrogen atoms would have struck its surface. Microscopic dust grains would have collided with it, a faint, persistent rain on its skin. The weak but eternal ultraviolet light from distant stars would have processed its surface, breaking and reforming chemical bonds. Over eons, this interstellar weather changed it. It was not travelling in a void, it was travelling with the medium breathing it in, being shaped by it. When we see 3A Atlas, we are not just seeing an object, we are seeing a record of its journey. Its surface is a history book written in the language of interstellar chemistry. So what is this space, this thin ocean between the stars? It is not a barrier. It is the connection. It is the connective tissue that binds the galaxy together. It is a graveyard and a nursery all at once. It's a graveyard holding the leftover material, the ashes of stars that died billions of years ago. And it is a nursery providing the raw material for stars that are yet to be born. Within this thin ocean, gravity is patient. Over millions of years, it slowly pulls this diffuse mist together. The gas and dust gather, forming vast dark clouds. Inside the hearts of these clouds, new stars and new planetary systems ignite. This interstellar medium is the cosmic ecosystem. It is the beginning and the end, the alpha and the omega of stellar life. It is the eternal connection that links our sun to its stellar siblings, that links the galaxy's past to its future. Our solar system is not an isolated island. We are just a small harbour on the shore of this vast, dark and living sea, and our visitors Oumuamua and 3 Atlas are simply messengers from that great ocean, reminding us that we are part of something much, much bigger. This cold, empty ocean of interstellar space is the rule. It is the default state of the universe, vast, dark and silent, but it is not the only state. Dotted throughout this endless ocean are the exceptions. They are the islands. These are the places of warmth, light and gravity. They are the star systems. From the blackness of the void, they would look like tiny, brilliant refuges, oases of energy in a desert of cold. Each one is a cosmic campfire holding back the night. Most of the universe's matter is gathered in these places. Here, chemistry happens, complexity is born, and the universe truly comes alive. Our lonely traveller 3I Atlas came from one of these islands. It is a piece of cosmic driftwood, a fragment of a home it can never return to. It was born in a place of light, but was violently exiled, cast out from its family into the great ocean. Its journey is one of silence and memory, carrying the chemical fingerprint of its birthplace. We cannot follow 3 Atlas back to its specific home. That island is unknown, lost across unimaginable distances and billions of years. But we can visit a place just like it. We can travel to a place where new islands of light are being built right now. Let us turn our gaze toward a place that humans from their tiny blue island have long admired. We are moving toward the constellation of Orion the Hunter. Below his famous 3-star belt there is a star that looks a little fuzzy, a little strange. As we get closer, this fuzzy patch begins to grow, filling our vision. This is no star, this is the Great Orion Nebula. It is not a place of chaotic explosions or violent crashes. To look at the Orion Nebula is to look at a masterpiece of cosmic art, a painting woven from gas and light. It is an enormous cloud, a celestial landscape stretching 24 light-years across. That is a distance so vast that our minds can barely hold it, trillions upon trillions of miles. It is a cathedral of creation. The cloud itself is a giant stellar nursery. This is where stars are born. As we drift closer, the colours are overwhelming. The cloud is not black. It is a canvas of breathtaking glowing colours. We see vast regions that glow a deep, vibrant pink. This is the signature colour of hydrogen gas, the most common element in the universe. Deep within this cloud, newborn stars have just turned on. Their intense, energetic light shines onto the surrounding hydrogen gas, exciting it and causing it to glow just like the gas in a neon sign. Woven through the pink are delicate ribbons of blue and purple. This is light from the brightest new stars reflecting off microscopic particles of dust, and cutting through it all are dark, jagged lanes. These are not empty space, they are the opposite. They are regions where the gas and dust are so thick, so dense, that they block all light from behind like a thick column of smoke. We are not watching a violent event, we are watching a process of slow, patient creation. The nebula is a giant, churning and beautiful incubator. Let us drift past the glowing outer layers, past the curtains of pink light and into one of those dark, dense lanes. Here it is colder. The light from the nearby stars is blocked. In this quiet darkness, the universe's most patient and powerful force is at work: gravity. In this cloud, there are billions and billions of hydrogen atoms, along with a sprinkle of helium dust and ice. For the most part, this gas just floats. It has its own pressure, its own slight warmth, which causes it to spread out. But gravity is always pulling. It is a quiet, relentless whisper, always trying to pull things together. In the vastness of the cloud, this pull is weak, but the cloud is not perfectly smooth. Some regions, just by pure chance, are a tiny bit denser than others. In that slightly denser patch, gravity has a slightly stronger grip. It whispers, "Come here." It pulls in a few more hydrogen atoms from its neighbours. Because it now has more atoms, its gravity gets even stronger. It is a process that feeds on itself. As the clump gets bigger, its pull gets stronger and it pulls in more material faster. The prompt called this "like drops of water on a window." That is exactly right. A tiny drop forms and then other smaller drops slide down and merge with it, making it bigger, which in turn gives it the strength to pull in even more. This process does not take minutes. It takes hundreds of thousands of years. As we watch this region, we see a giant dark cloud of gas slowly, inevitably beginning to collapse in on itself. As it collapses, it begins to spin. Anything in space that pulls itself together will spin just like an ice skater pulling in their arms. The cloud spins faster and faster, flattening out into a huge dark disk with a dense, tight clump forming in the very center. This central clump is the seed of a star. It is not a star yet, it is a proto-star. This is where the real magic begins. All of that gas falling inward doesn't just pile up, it crashes together. And when you squeeze gas, it gets hot. The center of this collapsing clump, crushed by the weight of all the material falling on top of it, gets hotter and hotter. First it is just warm, then it's thousands of degrees, then it reaches millions of degrees. The pressure at the core is unimaginable. The hydrogen atoms are no longer gentle floating gas. They are a superheated, frantic swarm, squeezed together so tightly that they have nowhere to go. And then a critical moment is reached. When the temperature at the core hits about 10 million degrees Celsius, a new process ignites. The hydrogen atoms, which have spent their entire existence avoiding each other, are now moving so fast and are packed so densely that they slam into each other and fuse. They stick together. In this fiery forge, 4 hydrogen atoms merge to become one new heavier atom, helium. This process, called nuclear fusion, changes everything. When the hydrogen atoms fuse into helium, a tiny amount of their mass is not needed. This leftover mass is converted into pure energy, a tremendous amount of energy. This is the heartbeat. The proto-star, which was just a dark, hot clump of gas, suddenly wakes up. A new powerful light ignites in its core. A wave of energy and heat blasts outward, fighting against the crushing force of gravity. A star is born. This new star is a violent, beautiful thing. It immediately lights up its cave. The intense new light and a powerful solar wind, a stream of particles blast away the remaining gas and dust of its cocoon. The dark, cloudy region is evaporated from the inside out, revealing the brilliant young star at its center. The star has settled into a stable life, a perfect balance between gravity trying to crush it and its new fusion engine pushing outward. It will keep burning like this, turning hydrogen into helium for billions of years. This is how an island of light is created. But what about the rest of the material? What about that huge spinning disk of leftover material that was orbiting the star as it formed? This is the second part of the creation story. This is the birthplace of planets, and this is the birthplace of 3i Atlas. This protoplanetary disk is still orbiting the young star. It is a vast, flat, spinning ring of gas, dust, rock, and in the outer regions, ice. It is a giant chemistry experiment. Close to the new hot star, it is too warm for ice to survive. All the ice has been boiled away. Only tiny grains of rock and metal are left. These grains of dust are like cosmic dust bunnies. They are sticky. They bump into each other and merge. Over millions of years, dust grains become pebbles. Pebbles collide and stick together to become rocks. Rocks become boulders. Boulders become planetesimals, small developing worlds miles wide. And these planetesimals, with their growing gravity, pull in all the other rocks and boulders in their path, eventually clearing their orbit and becoming the rocky planets, like Mercury, Venus, Earth, and Mars. But farther out away from the star's intense heat, it is much colder. We cross a critical boundary that scientists call the frost line. Beyond this line, it is cold enough for ice to exist. And in this part of the disk, there isn't just rock. There is rock and ice, lots and lots of ice, frozen water, frozen methane, frozen ammonia. This ice acts like a cosmic cement. It is incredibly sticky. The little grains of rock and dust are now glued together by ice. This allows them to grow much faster and much bigger than their rocky cousins near the star. They quickly grow into enormous cores of rock and ice, many times the size of the entire Earth. And because these cores are so massive, their gravity is strong enough to do something the inner planets could not. They begin to suck up the vast amounts of hydrogen and helium gas left over in the disk. They wrap themselves in thick, massive atmospheres, becoming the gas giants and ice giants of the system like Jupiter, Saturn, Uranus, and Neptune. Each star system, each island is a unique experiment. Maybe the disk was small, maybe the giant planets formed in different places. The exact recipe of chemicals, the timing, the chaos, it is never the same twice. But in all of this planet building, there is a lot of scrap. Not all the material gets used. In the inner system, the leftover rocky bodies that never became planets are what we now call asteroids. And in the outer system, out past the giant planets, there are trillions of leftovers from the cold region. These are the icy, rocky snowballs. They are the construction scraps, the unused bricks of ice and rock that failed to join a giant planet. This is what 3E Atlas is. It is a comet. It is a perfect frozen fossil from the birth of its solar system, a chemical time capsule containing the exact same material, the dust, the ice, the organic molecules that formed its island billions of years ago. For a long time, 3E Atlas orbited its young star peacefully, a forgotten piece of trash in the freezing cold darkness of the outer system. But new solar systems are chaotic. They are not stable. The giant planets with their massive gravity are like gravitational bullies. They slowly move around their orbits, shifting their immense pull, stirring up all the leftover scraps. One day our 3E Atlas, on its long, slow orbit, drifted a little too close to one of these new giant planets. The planet's gravity grabbed it, but it didn't pull it in. Instead, it acted like a giant gravitational slingshot. In a terrifying, brief and violent encounter, the giant planet's motion was transferred to the little comet. 3E Atlas was accelerated to an incredible speed. It was flung so hard that it broke free from the gravity of its own star. It was exiled. It was shot out of its home, out of its warm island of light, and cast away into the great cold ocean of interstellar space. It left the colourful nursery of its birth and began its new life a lonely wanderer, a messenger from a lost world travelling for billions of years across the dark. We have looked closely at the houses of the cosmos. We've seen our own home, the star we call the sun, a sphere of brilliant fire that gives us life. We've imagined the distant home of 3I Atlas, another star, another house with its own family of planets. From our perspective, these stars feel like the most important places in the universe. They are the local fireplaces, the centres of their own small neighbourhoods. But it is time to zoom out. These houses, our sun, the star of 3 Atlas, and countless others, are not scattered randomly in an empty void. They are in fact citizens of a single colossal structure. They are just two homes out of hundreds of billions, all bound together in a city of stars so vast it defies imagination. The light from one end of this city takes 100,000 years to reach the other. This city has a name, one given to it by the ancient Greeks, who looked up and saw a faint shimmering band of light splashed across the night sky. It looked to them like a Milky Circle or a Milky Way. We call it the Milky Way Galaxy. When you go out on a clear night far from the lights of human cities, you can still see this band. It is not a cloud. It is the light of billions of stars so far away and so densely packed that our eyes blur them together into a single faint glow. What you are seeing is the city from the inside. You are standing on a street in a massive city, looking down the main street, seeing the lights of the downtown core and the districts beyond all blend into one, the living storm. Our city, the Milky Way, is not a static object. A photograph, even a beautiful one, is a lie. It freezes a single instant, making the galaxy look like a beautiful, fragile pinwheel frozen in glass. The truth is far more dramatic. The Milky Way is a living, breathing, violent and creative system. It is a self-contained universe of creation and destruction. It is not a pinwheel. It is a spiral storm of light, gas and dust constantly churning and evolving over billions of years. What gives it this life? First, there are the stars themselves, the lights of the city. There are at least 100 billion of them, and perhaps as many as 400 billion. Like any city, it has different populations. In the bright central core and in a vast spherical halo around the city, the stars are ancient and reddish, the old-timers who have been there since the beginning. In the suburbs where we live, the spiral arms, we find a mix of old stars and new hot blue stars, young and brilliant living, fast and dying young. Second, there is the atmosphere of the city, vast clouds of gas and dust. This is the interstellar medium. This is the breath of the galaxy. This is the raw material from which new stars are born. We see these clouds as beautiful, colourful nebulae. These are the star nurseries, the maternity wards of the galaxy. Here gravity pulls the gas together, compresses it and ignites the fire of a new star. This is a cycle. Stars are born, they live for millions or billions of years, and then they die. When massive stars die, they explode in a supernova, a blast so bright it can outshine the entire city for a few weeks. This explosion scatters new heavy elements, iron, oxygen, carbon, the very materials that make up planets and people, back into the gas clouds. The galaxy recycles. The gas is enriched and the next generation of stars and planets is born from the ashes of the last. You, the person reading this, are made of that recycled star stuff. Third, there is the invisible structure. The stars and gas we see are only a tiny fraction of the city's total mass. Most of it is something we call dark matter. We cannot see it, we cannot touch it, and we do not know what it is, but we know it is there. We can feel its gravity. This dark matter is the scaffolding of the city. It is the immense invisible mass that holds the whole swirling storm together. Without it, the stars would simply fly off into the void. The city would dissolve. Together, these parts create a massive flat disk with a bright central bulge, all surrounded by a faint halo. The disk is not uniform, it is organized into districts, the spiral arms. These arms are traffic jams. They are regions where the gas is compressed, triggering those new bursts of starbirth. This is why the arms are so bright. They are lined with new, brilliant blue stars like avenues lined with bright streetlights. Our place in the city. So where are we in this monstrous, beautiful city? We are not in the center. The center of the galaxy, the downtown core, is a terrible place for life. It is crowded, chaotic, and flooded with lethal radiation. Stars are packed in so tightly that their gravity would disturb our solar system and fling our planets away. Instead, we live in the suburbs. We are about 26,000 light-years from the central core, roughly halfway between the center and the city's edge. We are in a quiet, stable neighborhood. Specifically, our sun is just one star in a smaller minor avenue called the Orion Arm, or sometimes the Orion Cygnus Spur. This is not even a main arm of the galaxy. It is a smaller local lane that branches off between two of the great grand arms, the Sagittarius Arm, which we see when we look toward the downtown center, and the Perseus Arm, which we see when we look out toward the city's edge. Our suburban location is perfect. We are far enough from the chaotic center to be safe, but we are not so far out that we are in the countryside where the gas is thin and lacks the heavy elements needed to build planets like Earth. We are in what scientists call the galactic habitable zone, the just right orbit for life to emerge. We are in a quiet, safe and resource-rich part of the city, the Great Journey. Because the galaxy is a living, spinning storm, everything in it is moving. You are not sitting still. Right now, you, me, the Earth, and our entire solar system are hurtling through space at a speed that is difficult to comprehend. We are racing around the center of the Milky Way at over 800,000 kilometers per hour, or about 230 kilometers per second. This is not a metaphor. This is a physical, measurable speed. At this velocity, you could circle the entire planet Earth at the equator in less than 3 minutes. We are all on a grand orbital journey. We are riding this carousel, moving through the Orion Arm, weaving through the traffic of other stars, all while being pulled in a great sweeping arc around the center of our city. Even at this insane speed, the city is so enormous that the journey takes an almost eternal amount of time. To complete just one lap around the Milky Way, one full orbit takes our solar system over 200 million years. Think about that. 200 million years. This length of time is called one galactic year, or one cosmic year. Let's put this in perspective. The last time our solar system was in this exact spot in the galaxy, one galactic year ago, dinosaurs were just beginning to walk the Earth. The Triassic period was dawning. The continents were merged into the supercontinent of Pangaea. Our planet Earth is about 4.5 billion years old. That means in its entire lifetime it has only made this journey around the galaxy about 20 or 21 times. Earth is only 21 galactic years old. And humans. Our entire species, Homo sapiens, has only been around for about 300,000 years. We have only existed for a tiny, tiny fraction of one galactic year. We are just a snapshot. We are passengers who got on the train a few moments ago, on a journey that has been repeating long before we ever existed, and will continue long after we are gone. The anchor in the heart. What are we orbiting? What is the engine or anchor at the center of this 800,000 kilometer, mile-per-hour journey. For decades, astronomers wondered. The centre of our galaxy in the direction of the constellation Sagittarius is hidden from us by vast clouds of gas and dust. We cannot see it with normal light, but with radio waves and infrared light we can finally pierce the veil. And what we found there is the motive force of our city. At the precise gravitational centre of the Milky Way there is a supermassive black hole. The prompt was clear: this is not a monster. It's crucial to understand this. A black hole is not a cosmic vacuum cleaner. It does not suck things in, it is simply an object with gravity. If you were to replace our Sun with a black hole of the exact same mass, nothing would happen to Earth. We would continue in our orbit just in total darkness. The gravity is the same. The black hole at our galaxy's centre is an anchor. It is an object of almost unimaginable density and mass. We have given it a name, Sagittarius A star, pronounced A star. It is supermassive because it has the mass of 4 million of our suns. All of that material 4 million suns worth is crushed into a point so small it would fit easily inside the orbit of the planet Mercury. This is the anchor. Its immense gravitational pull combined with the collective gravity of all the stars in the central bulge is what holds our galaxy together. It is the drain around which the entire storm of the Milky Way spins. It provides the central massive point that stabilizes the orbits of all 100 billion stars, including our own. Our anchor is quiet. It is not feeding on huge amounts of gas right now, which is very good for us. When these supermassive black holes do feed, they become the brightest objects in the universe. Quasars blasting out jets of energy that would sterilize our side of the galaxy. But ours is napping. It sits in the dark, a silent king, holding its city together, with its invisible gravitational threads. It is the heart, the anchor, the engine. And we in our quiet suburban arm continue our long 200 million year lap around it, just as we have done for more than 20 circuits of this great living city of stars. To continue a piece of writing is a special kind of challenge. It is different from starting with a blank page. When you start fresh, the possibilities are endless. But when you are asked to continue, you have a new set D of responsibilities. You must first understand what came before. You have to pick up a thread of thought, a particular voice and a set direction. It's like joining a conversation that has already begun. You cannot simply shout your own ideas. You must first listen to the rhythm of the discussion and then add your own words in a way that makes sense, in a way that respects what has already been said. This task becomes even more specific when the request is to write in English using easy-to-understand words and to write out any scientific symbols fully. And to do all of this for a significant length, something like 2,000 words, adds another layer of difficulty. This is not just a request for information, it is a request for a specific style of communication. It is a request for clarity, accessibility, and endurance. Let us first talk about the idea of using easy-to-understand words. This is often called plain language. Some people mistake plain language for simple-mindedness, but this is wrong. The goal of plain language is not to dumb down an idea. The goal is to be radically clear. It is to build a bridge between the writer's mind and the reader's mind, and to make that bridge as strong and as short as possible. Think about it this way. Complex words and jargon are like a locked gate. If you are a member of the club that has the key, for example, if you are a scientist, a lawyer, or a technical expert, then that jargon is very useful. It is a shortcut. A doctor can say one complex medical word to another doctor, and it communicates a whole paragraph of meaning. But for anyone outside that club, that word is not a shortcut. It is a wall. It stops them completely. The reader feels excluded and the message is lost. Writing in simple terms is an act of generosity. It shows that the writer cares more about the reader's understanding than about sounding impressive. It takes more effort to write simply. The American writer Mark Twain is often credited with saying, "I didn't have time to write a short letter, so I wrote a long one instead." The same idea applies to clarity. It is easy to write a confusing, complicated sentence. It takes time and hard work to find the simple, clear way to say the same thing. When we are asked to do this in English, it adds another important layer. English is for many people around the world a second or third language. They may be experts in their own field, but they might not have the specialized English vocabulary. Using plain English makes the information accessible to a much wider global audience. It is a way of being inclusive. If you write a brilliant idea about science or philosophy, but you lock it behind a wall of difficult academic English, who are you really writing for? A small group of academics or for the world? Simple language chooses the world. This brings us to the next very specific instruction. Scientific symbols are written out as words. This is a powerful extension of the plain language idea. Let us explore what this means in practice. In a technical paper, a scientist might write H2O, or CO2, or 100 degrees Celsius. They use the symbols. These symbols are again a shorthand for experts. They're fast to write and fast to read if you already know what they mean. But for the average reader, they are speed bumps for the brain. When a reader who is not a scientist sees CO2, their mind may pause. They might have to stop and think, okay, C is carbon, O is oxygen, 2, write carbon dioxide. This brief pause is a moment of friction. It breaks the flow of reading. The reader is no longer thinking about the idea what carbon dioxide does in the atmosphere, for example, but is instead spending mental energy just translating the symbol. Now consider the alternative. If you write the words carbon dioxide, there is no translation needed. The reader's brain reads the words and immediately understands the concept. The connection is instant. The same is true for H2O. Why use the symbol when the word water is so much more direct, more visual, and more familiar to every single human being? The word water connects to our experience of drinking, swimming, and rain. The symbol H2O connects to a high school chemistry class, which for many people might not be a pleasant memory. Let us think about temperature. Writing 100 degrees Celsius instead of the symbol 100 degrees does something very important. It slows the reader down, but in a good way. It forces them to read the full concept 100 degrees and the system of measurement Celsius. This is much clearer, especially for an international audience, where some people use Celsius and others use Fahrenheit. Writing it out removes all confusion. You're not just presenting data, you're explaining it as you go. This idea goes beyond just chemistry or temperature. It applies to mathematics as well. A writer could use a symbol like the Greek letter pi. But for a general audience, it is much clearer to write the number pi, or even to explain it as the number that represents the ratio of a circle's circumference to its diameter, which is approximately 3.14. The symbol is efficient for a mathematician, but the words are meaningful for everyone. When you spell out these scientific and mathematical terms, you are changing the very tone of the writing. You are moving away from a cold, technical and objective style that is common in scientific papers. You're adopting a warmer, more descriptive and more human style. It feels more like a teacher or a guide is speaking to you, patiently explaining each concept so that you're sure to understand. It's a style that builds trust. The reader feels that you're on their side. You're not trying to test them, you're trying to help them. This creates a piece of writing that is incredibly accessible. A high school student could read it. An expert in a different field could read it. A person learning English could read it. And importantly, even another expert in the same field could read it and find it refreshing. No one, no matter how smart, has ever complained that something was too easy to understand. Now we must have faced the final challenge, how to do all of this for about 2,000 words. This is the real test. It is one thing to be clear and simple in a short paragraph. It is another thing entirely to maintain that clarity, that simple language, and that no symbol rule for a very long text. The biggest danger when writing a long piece with simple words is padding. Padding is filling the page with words just to meet a word count. It is repeating the same idea over and over in slightly different ways. It is using 10 words when 3 would do. This kind of writing is boring. It is not simple and clear, it is just simple and empty. It disrespects the reader's time. The true challenge is to achieve length not through padding, but through depth. If you must use simple words, you cannot use complex vocabulary as a crutch to make your writing sound smart. You must rely on the strength of your ideas. To fill 2,000 words, you have to explore the topic from every possible angle. You have to provide many examples. You have to use analogies and metaphors to connect new ideas to old ideas the reader already understands. Let's imagine we are writing about the topic of carbon dioxide for a long text using these rules. We would start by introducing the term carbon dioxide. We would not use the symbol. We would then explain what it is in simple terms. We would say it is a gas. We would explain that it is invisible and has no smell. We would explain where it comes from. We would talk about how we make it, how every human breathes it out. We would write, when you breathe in, you take in oxygen. When you breathe out, you release carbon dioxide. That is clear. But to reach 2,000 words, we must go deeper. We would then talk about other things that make carbon dioxide. We would talk about burning things. We would explain that when wood burns in a fire, it releases this gas. We would explain that when we burn fossil fuels like coal or oil or natural gas to power our cars and our homes, this also releases a very large amount of carbon dioxide. We would then have to explain what happens to all this gas. We would talk about the atmosphere. which is the blanket of air that surrounds the Earth. We would explain that carbon dioxide is a natural part of this blanket, but we can go deeper still. We would explain the role of plants. We would write about photosynthesis, but we would not just use that one big word. We would explain it. We would say plants do something wonderful. They breathe in carbon dioxide, they use sunlight for energy, and they use this air and the water to make their own food. In the process, they release the oxygen that we need to breathe. We would call it a beautiful partnership. Then we must explore the problem with carbon dioxide, which is a major part of the modern conversation. We would explain the greenhouse effect. Again, we would use a simple analogy. We would say the carbon dioxide in the atmosphere acts like the glass in a greenhouse, or like a blanket. Sunlight comes in and warms the Earth. Some of that warmth tries to escape back into space, but the carbon dioxide and other gases in the blanket trap some of that warmth. This is good, it keeps our planet warm enough for life. But then the depth. The problem is that humans are now adding extra carbon dioxide to the blanket by burning so much fuel. We are making the blanket thicker. When the blanket is thicker, it traps more heat. This is causing the whole planet to get warmer. We would write global warming or climate change. We would explain the difference. We would talk about what a warmer planet means, melting ice, rising sea levels, which we would write as the level of the ocean is getting higher, and more extreme weather. See how far we have come. We started with a simple rule, write out carbon dioxide, and it has forced us to go from a simple definition to explaining the entire planet's climate system. We have done it all in simple words. We have not used a single symbol. We have used analogies, a blanket, a greenhouse to make the ideas clear. To reach 2,000 words, we would continue this. We would explore solutions. We could talk about renewable energy. We would explain what that means, energy from sources that do not run out like the sun, solar power or the wind power. We could talk about planting more trees because we remember that trees breathe in carbon dioxide. This is the secret to writing a long, simple and clear text. The length does not come from complex words. The length comes from a deep, patient and thorough exploration of the idea. It comes from answering every why and how that a reader might have. It comes from giving examples, telling stories and using comparisons. So to continue writing in this way is a profound commitment. It is a promise to the reader. The promise is I will not try to impress you. I will try to inform you. The promise is I will not hide behind technical jargon. I will do the hard work of translating complex ideas into plain English. The promise is I will respect your time. I will not waste your attention with confusing symbols or empty padding. I will fill this space with real, meaningful and well-explained ideas. To write 2,000 words in this style, simple, clear, no symbols and continuous, is to build a large, strong and beautiful house using only common, simple bricks. The final result is not impressive because each brick is fancy or complicated. The final result is impressive because of the scale and clarity of the structure. It is a house that anyone can enter, walk around in and understand. It is a house built for everyone. This is the task. It requires patience, empathy for the reader, and a deep belief that big, important ideas can and should be made accessible to all. It is a discipline and a worthy one to practice. The request to write in this manner is not just a set of instructions. It is an invitation to communicate in the most powerful way possible with absolute clarity. We began our journey tonight so long ago with a strange and lonely traveller, a visitor from an unimaginable distance given the name 3i per Atlas. It was just a fragment, perhaps a tiny piece of another world, another solar system sent tumbling through the dark for millions or even billions of years. It swept past our sun, a silent messenger, a ghost from an unknown star. And then it continued on its way, fading back into the endless night, leaving us with more questions than answers. It was a reminder, a single fleeting visitor that told us our home, our solar system, is not an isolated fortress. It is an island connected by a vast dark ocean to other islands, trillions of them. And so we end our exploration here, not on solid ground, but in the quiet, gentle drift of space. We are floating. We are passengers on a small blue world sailing through a universe that contains, well, the numbers lose their meaning. We used to look up and see only small lights. Now we know that every one of those lights is a sun. Our own galaxy, the Milky Way, contains hundreds of billions of suns. And most of those suns likely have their own families of planets, worlds of rock worlds, of ice worlds, of giant swirling gas. And our galaxy, this magnificent spiral of light that we are a part of, is only one of perhaps 2 trillion and other galaxies scattered through the observable cosmos. Trillions of worlds, trillions of chances, trillions of homes. We are adrift in an ocean of possibility so vast that our minds cannot hold it. In the face of all this impossible style and endless space, what are we? It is the oldest question. We stand on our small world under that same blanket of stars and we feel so very small. It is easy to feel insignificant, a tiny flicker of life on a speck of dust, lost in a cosmic ocean that is too large to even comprehend. We live, we breathe, we love, and then we are gone. Does any of it matter? What is our place in this grand silent dance? The answer to that question is perhaps the most beautiful secret in all of science. You are not separate from this universe. You are the universe. Think about what you are made of. The very atoms that build your body, the carbon that forms the framework of every one of your cells, the calcium in your bones, the iron in your blood that carries life, that carries the oxygen you are breathing in and out right now. These things were not made on Earth. They were not created when our planet was formed. They were forged at the heart of a star. Imagine a star long ago, long before our sun was even a dream of dust. A star far more massive and brilliant than our own. For billions of years it lived, and in its core it was a factory. It took the simplest atoms, hydrogen and helium, and under unimaginable pressure and heat it cooked them. It fused them together into carbon, into nitrogen, into oxygen, into iron. And then, at the end of its life, it did the most generous thing imaginable. It exploded. A magnificent, brilliant supernova scattering those precious heavy elements across the galaxy like a farmer scattering seeds. That stardust drifted through the void for eons. It mixed with other clouds of gas, it swirled and it waited. Eventually a new cloud began to collapse and our sun was born, and the leftover dust, the recycled remnants of that ancient exploded star, that dust became the planets, it became the Earth. And on this Earth, that same carbon, that same nitrogen, that same iron, it learned to organize itself. It became the first simple life. It became the oceans, the trees, the air. And eventually, after billions of years of slow, patient evolution, it became you. You are not just living in the universe. You are the universe. You are the cosmos become conscious. The iron in your blood is the literal ghost of a long-dead star. The carbon in your breath was forged in a stellar furnace. You are a living, breathing, thinking piece of the cosmos. You are a way for this vast, silent universe to know itself. When you look up at the stars, it is the universe looking back at itself. When you wonder, when you feel awe, when you feel love, that is the cosmos experiencing itself through you. So when we see a visitor like 3 Atlas, that strange piece of rock from another star, it is not an alien, it is not an intruder. It is in the deepest sense family. It is made of the same stardust we are. It is just another part of the story. These mysteries, these deep silent voids, these signals from far away, they are not threats. They are reminders, they are whispers from the great cosmic ocean gently telling us that the story is so much larger, so much more intricate than we can ever imagine. They are invitations to be curious. They are permissions to feel awe. And now as you settle in, as you listen to the silence growing around you, just feel that connection. Feel the gentle, slow movement of the earth. You may feel still in your bed, but you are in motion. You're on the surface of a planet, slowly, gracefully spinning, turning us from night to day and back to night. A quiet, constant, steady rhythm. Feel that planet your home as it sweeps through space on its long yearly journey around our sun, a massive silent orbit that we have taken every single year of our lives. And feel our entire solar system, our sun and our Earth and all the other planets, feel us moving as one. We are part of a great swirling river of stars. We are journeying through our neighborhood in the Milky Way galaxy. We are part of the grand, slow, majestic dance of hundreds of billions of stars all turning together around the galaxy's bright center. You are part of this dance. You have always been a part of it. You are not lost in the cosmos. You are a fundamental part of it. You are not a stranger here. You're made from this place. The universe is not out there. It is in you. You are home. As you lie here, feel the weight of your body. Feel the stardust you are made of settling in for the night. Feel the gentle pull of the earth holding you safe. Feel the quiet rhythm of your own breathing, in and out. You are a part of this great silent music of the cosmos. And now, it is time to rest. It is time to let go, let the questions fade, let the wonders settle, let the silence hold you. You are home, you are safe, and all is well. Sleep now, sleep.